Now all of you join with your roll number. You rename yourself to your roll number. Yes, students, how many have joined? Only 10 students. What about others? Are you able to hear me, students?
వాళ్ళు మెక్సివిల్ దాంట్లో ఉన్నారు
కాదురా, అది రావట్లేదు కదా, అది మాకు జాయిన్ అని రావట్లేదు. మీకు వస్తుందా?
మాకు వస్తుంది మ్యామ్.
అందులో జాయిన్ అవుతామంటే జాయిన్ ఆప్షన్ లేదు. ఇప్పుడు వస్తుందా? ఇప్పుడు వస్తుందా?
మార్నింగ్ కూడా వచ్చింది మ్యామ్.
ఏ రాలేదా? మాకు రావట్లేదు. సరే, అందరిని ఒకసారి చెప్పవా? యశ్వంత్, you tell all others to join this meeting.
Okay ma'am.
Tell them fast because your PP madam class I'm going to take Python programming. So if you come fast, then we'll start. I kept messaging group also to join same link as English.
Stop it.
You join with your roll number, ma. Okay, students, are you able to see my PPT? Yes?
Yes, ma'am.
Okay. I think last class we have done till 6 problems, right? You
Yes,
finished
ma'am.
6? Okay, so
Yes,
7th
ma'am.
one, all of you copy down in your notes. Take down this question. So 7th problem in our question bank is evaluate the value of carrier concentration if the RH of a specimen is 3.66 into 10 to the power of -4 meter cube per coulomb. So all of you start copying this problem. Even solution also have done there. First you copy the problem, then I'll discuss solution. All of you copy the question mark. Question at the copy
నీట్గా
important question. Satisfy Lagrange. Then the given function is satisfied or not means what is the first condition for the Lagrange? The given function is continuous and the second condition is differentiable. Okay. If one is the given function as far as the standard of x is differentiable, definitely differentiable. Okay. Therefore, from the function f dash of x is equal to what? 1 by convex x square. Exists in open interval a gamma b. So did you copy question mark? Finished? So shall we discuss solution? Okay. I think very simple problem. Okay. So what is given in this problem? You were given value of RH. What is RH, students? What is RH? RH represents Hall coefficient. Okay. So we have taken two formulas for RH. So in the previous 5th and 6th problem, we have used different formula for RH. Now in this problem, we are using what is the formula for RH? RH is 1 divided by NE. What is N? N is called carrier concentration and E is charge of electron. So E is charge of electron. And what is the value of charge of electron? 1.6 into 10 of minus 19 coulombs. Okay. So here now RH value is given. Data is this. And we are supposed to find carrier concentration. So we are making use of this formula. But we need to find N. So from this formula, what is N? N is 1 by RH into E. And what is the value of RH given? 3.66 into 10 of minus 4. And charge is 1.6 into 10 of minus 19. And if we simplify, what is the value we are going to get for carrier concentration? 1.7 into 10 of 22 atoms per meter cube or charge carriers per meter cube. I hope you people have understood. Any doubts in this problem, students? Just copy it fast so that we can go for next problem. Today I am going to start third module also. So 3 more problems are left. We'll finish those problems. So copy it fast, all of you. Finished? Shall I change slide?
Yes, ma'am.
No, ma'am, 1 minute.
Fast, fast, fast. Copy it fast. I'm changing slide now. Okay. Now just look at the 8th problem. So what is given in the 8th problem? Here also you are supposed to find
Ma'am, slide not changed, ma'am.
Not changed, huh? Okay, wait. Why is this problem coming? Now, are you able to see change slide?
Yes, ma'am.
So now, look at this problem. So what is given in this problem? Of course, first here also we need to find density of charge carriers. Who is that fellow? So we need to find density of charge carriers. Again, we were given value of Hall coefficient. I think this problem is just like previous one. See, you people have to understand that carrier concentration and density of charge carriers are same. Okay, so don't get confused. So what is the other name given for carrier concentration, which is also called density of charge carriers? So I think this problem is same as we have done in 7th one. So we know value of Hall coefficient, and one thing students, here Hall coefficient value, it is given as negative. Are you able to see Hall coefficient value? It is given negative. What does it indicate? What do you mean by having negative Hall coefficient value?
It is moving in opposite direction.
It's not about opposite direction. I told you RH is negative if your charge carriers are electrons. It means that you are talking about n-type semiconductor, because in n-type semiconductor majority charge carriers are electrons. Whereas RH is positive if your majority charge carriers are holes, and holes are present in majority in p-type semiconductor. So if I get negative, it means that I am dealing with electrons, negative charge carriers. Is it clear, students? Okay. So, but when we are making use of this formula, we neglect this sign. Just we'll take magnitude. What is the magnitude? 6.85 into 10 power minus 5 meter cube per coulomb. C stands for coulomb. Okay. Here also we need to find n value. So same formula we are using. So if you just modify this formula, n it is given as 1 by RH into E. RH is 6.85 into 10 power minus 5 into, what is the charge of electron? 1.6 into 10 power minus 19. And if we substitute, this is what we are going to get. So just quickly all of you copy. So students over, shall I change slide?
Yes, ma'am.
Okay. So coming to ninth one, are you able to see this? Change slide.
Yes, ma'am.
Okay, so just note down the question and I'll discuss solution. So what is the question given here? Electron mobility and hole mobility in silicon. It is given. What is the value of electron mobility? It is 0.135 meters square per volt second. So meter square per volt second. So units are very important. What is the unit for Hall coefficient? Unit for Hall coefficient is meter cube per coulomb. But coming to mobility, what is the unit? Meter square per volt second. And what is the value of hole mobility? It is 0.048 meter square per volt second respectively. And if carrier concentration is 1.5 into 10 power of 16, we need to find resistivity of silicon at room temperature. So this is completely new problem. So we just copy question, then we'll go through the solution. Okay, students, all of you start copying fast. Sorry, my again technical issues here. Then I read that. Come on, but I will check them next time. And the reduction part. When I copy the reduction. So shall we continue with the solution, ma? Did you copy?
Yes, ma'am.
Okay. Now I think here we are making use of completely different formula. Yes, ma. So just look at the formula. So what is the data given? Now in the data given, we were given value of. Second, ma. I think we were given value of electron mobility and hole mobility. So here, and of course we are given value of carrier concentration. What is the value of carrier concentration? 1.5 into 10 power of 16 per meter cube, or I can write it as meter whole to the power of -3. And then we were given mobility of electron. Mobility it is denoted by mu. But here mobility it is given for both electron and hole. So mobility of electron it is denoted as mu e, and mobility of hole it is denoted as mu h, and these are the values given. And what is the unit? Meter square per volt second. Okay, and what we need to find? We need to find value of resistivity. This is what we need to find. Okay, now you are seeing previously I have taken this formula if you are able to remember. This is not Okay. So what is the formula? I think previously we have taken formula sigma is equal to Ne mu. What is sigma? Sigma is conductivity. I think I've used this formula before, okay, somewhere like in solving problems. And what is mu? Mu is mobility. But mu will take only if you are talking about mobility due to one type of charge carriers. But here mobility is because of two types of charge carriers, electrons and holes. So that's why in place of mu, we are going to take mobility of electron as well as hole. So this is our formula. So you need to remember this formula also. So in order to find resistivity, first I'll try to find conductivity. And what is the formula? Sigma is equal to Ne. N is carrier concentration, E is charge of electron, and here mu. In place of mu, we have taken it as combination of mobility of electron plus mobility of hole. And what is the value of carrier concentration? 1.5 into 10 power of 16 into, what is the charge? 1.6 into 10 power of minus 19 into, and we were given values of electron and hole mobility. Electron mobility is 0.135 and this hole mobility is 0.048. And if we just simplify it, what is the value of conductivity we are getting? We are getting it as 0.4392 into 10 power of minus 3 ohm inverse meter inverse. Look at the units. So what is the unit for conductivity? Ohm inverse, meter inverse. And once I know conductivity, I think it is easy to find resistivity. So this is resistivity of silicon. This is OF. So resistivity of silicon. And what is the relation between conductivity and resistivity? Resistivity is inverse of conductivity. And what is the value of conductivity? Just now we got 0.4392 into 10 power of minus 3. And if we simplify it, finally, what is the value of resistivity we are going to get? 2.2768 ohm meter. So this is the unit for resistivity. Okay, students, any doubts in this problem? I hope it is clear. Any doubts?
No, ma'am.
No,
Okay, just copy it then. We'll go for last problem. 5 plus 2 by 4. The second question I read that second question 5 plus 4 by 20 less than and inverse 2 less than 5 plus 2 by 4. 5 plus 2 by 4. Second question. So shall I change slide?
1 minute, ma'am.
Yes. B is equal to 2 and what about A? A is equal to 1 is 1. Let them be satisfied. Okay, now. So there are this part now, first part. All are copy this.
Completed, ma'am.
Okay, ma'am. So
Wait,
changing. Okay,
ma'am, wait.
okay. I'm not changing. Right, fast. Then we'll discuss last problem. Substitute the two values in the second equation, that is 2 minus 1 by 1 plus 2 square less than tan inverse 2 minus tan inverse 1 less than 2 minus 1 by 1 plus 1. That is 1 by 1 plus 4 minus 5 less than tan inverse 2 minus tan inverse 1 means 5 by 4 less than 1 by 2. From that 1 by 5, I will take minus 4, 5 by 4 from this side, that is plus 5 by 4 less than tan inverse 2 less than 1 by 2 plus 1 by 4. Finished?
Yes, ma'am.
Okay. So I'm changing slide now. I will go for last one. So this is our last problem. So here in this problem, we were given again same thing, Hall coefficient value. Okay, so this is the value of Hall coefficient. And apart from Hall coefficient, I think we were given value of electrical conductivity. So electrical conductivity is given. So what's the unit for electrical conductivity? 250 ohm inverse meter inverse. And we need to find, see here, Coulomb density and also mobility of charge carriers. So what is Coulomb density? Coulomb is nothing but the unit for charge. So here we are talking about charge density. Okay, ma. So here Coulomb density is nothing but we are talking about charge density, and this is one more name for carrier concentration. Don't get confused. So carrier concentration, it is taken as density of charge carriers or carrier concentration, Coulomb density, charge density. And apart from that, we are supposed to find even mobility of charge carriers. Okay, students. So just look at the data. First I'll discuss solution, then you can copy. So RH value is given. Again it is minus. So it means that we are dealing with electrons as majority charge carriers. And we were given value of conductivity, which is 250 ohm inverse, meter inverse. And we need to find density of charge carriers. Also we need to find mobility. So we make use of this formula. So just no need of taking minus, just 1 by NE. As I told you, we are going to neglect sign. Okay, so first we'll try to find N. N is given as 1 by RH into charge. RH value is 6.85 into 10 power of minus 5 and charge is this. So we are able to get Coulomb density. Now next step is to find mobility. First you take down this, then in next slide I'll show you how to find mobility. Okay students, just take it down fast. Finish, Ma? Finish? Any doubts for the first question? Finish? Very good. All right, and the second question. You have one question right now, understand? Have you copied this one? Shall I change slide?
RH దగ్గర 1 by NE లేకపోతే -1 by NE మ్యామ్
1 by NE పెట్టండి. Otherwise you get confused. Okay, 1 by NE only. Okay, ma'am. Prove that. 5 by 6. 1 by 5 root 3 less than 5 inverse 3 by 5 less than 5 by 6 plus 1 by 8. 5 by 6 plus 1 by 5 is 3 less than sin inverse 3 by 5 less than 5 by 6 plus 1 by 8. There is no reduction factor in this question. Directly asking only prove that the figure. That let us assume one function. What is the function from this? What is the function here? Yeah, for x is equal to what? Or ఇక్కడ చూడండి క్వశ్చన్ లో ప్రూఫ్ గా కల్చర్ బట్ యూకే రెక్టాంగిల్స్ రోస్ థియరమ్ కాన్స్టెంట్స్ అన్న కండిషన్స్ ఏమీ లేవు బట్ ఫ్రమ్ దిస్ టైప్ ఆఫ్ క్వశ్చన్స్ డెఫినెట్లీ ఫ్రమ్ ది రెక్టాంగిల్స్
So done.
Shall I change slide?
Yes, ma'am.
Take it on fast. And using the blender here for the first solution, let us consider f of x is equal to sin inverse x. Here, what are the intervals? We don't know the exact intervals here. 2, comma, b. By using rectangles, first we have to verify all conditions are satisfied or not for the given function. By using rectangles, we call it down. Let us take the first condition. Okay, ma'am, I'm changing slide. So this is the second half of problem. So what else we need to find in the problem? One second, my students.
మ్యామ్ మైక్ మ్యూట్ లో ఉంది మ్యామ్.
See here, so what else we need to find? We have seen that in problem, we are supposed to find Coulomb density as well as mobility. Gata. So we have calculated Coulomb density, which is nothing but charge density. Now we need to find mobility. So what is the formula for mobility? Conductivity is given as NE mu. Okay, ma. So from this, what is mobility mu? Mu is sigma by NE. Okay, so sigma is 250 and carrier concentration is this much and charge is this. So we'll get the mobility value like this. Okay, so meter square per volt second. This is capital V. Keep it as capital V per volt second. Right now. So I hope you have understood all those problems we have done in second module. So now I'm going to start third module also. So for your first CIE exam, you have first to end of modules. So 2 modules we have finished. And then we need to finish half of third module, which is lasers. Okay, that hardly it will take 3 to 4 classes. I think you got your schedule for CIE exams from 4th or 3rd month. You have your CIE exam from
Third.
third. That is Thursday, na, next week. Is it Thursday next week?
Yes, ma'am.
Okay, so it is in offline mode only.
Yeah, ma'am.
Okay. So anyway, don't worry, we'll finish syllabus. Even I am going to discuss question bank also. So that's why today I thought of starting lasers. Okay, ma. So if you are done with this slide, then I'll go for lasers. Third module. Okay. So shall I
Ma'am,
remove-
ninth problem, ma'am.
Emma?
Last one. Ninth problem, last one.
You want me to go to 9th problem?
Yes, ma'am.
Okay, going 1 second. This one? This one only?
Ma'am,
Yeah, copy it down fast so that we can start our third module. Okay, first part is lasers and second part is fiber optics. So second part is fiber optics. So for your first CI1 exam, you have lasers. So we need to finish lasers for your first CI exam. Okay, now before going into different topics of lasers, so we need to first understand what exactly is laser light. Okay, can you tell me what is the abbreviation of laser, students? Any idea? What is the full form of laser? What is the abbreviation of laser? Yes. What is the abbreviation of laser? L stands for light. Okay. A stands for amplification. So light amplification. And what is S? So light amplification by stimulated. So light amplification by stimulated.
Emission of radiation.
Yes. Light amplification by stimulated emission of radiation.
Radiation.
గడక చూడు అయిందా
Roll number 33, mute yourself. Okay, so light amplification by stimulated emission of radiation. And when we compare laser light with normal light, see this abbreviation of laser you will understand once we finish this laser topic. When we come to end of this laser module, so you are able to understand this full form, how exactly this light amplification is taking place and what is stimulated emission. So you can understand each and every term given here, okay, when we come to the end of this module. So first topic in this laser is we need to understand how laser light is different from normal light. So I think there are 4 characteristics of laser which is going to be make it different from normal light. So when compared with conventional light, what do you mean by conventional light? Conventional light is nothing but normal light. So conventional light is nothing but normal light. So here when we compare laser light with normal light, This is normal light. When you compare laser light with normal light, and what is normal light? Your tube light, okay, or sunlight, it is normal light. So this laser light, it has got four outstanding characteristics. So what are those four outstanding characteristics? First one is it has got property of directionality, and second one is it is monochromatic, and third property is it is highly intense, and fourth one is it is coherent. Okay, ma. So can you tell me what do you mean by directionality, students? What can be directionality? What do you mean by laser light being directional? Yes. What do you mean by being directional? So just copy these four characteristics. So what are the four characteristics of laser? It is directional, monochromatic, highly intense, and coherent. Now we are going to discuss about each and every characteristic. Okay. So I'm changing slide. Okay. So what do you mean by being directional? So see here, being directional means here laser light it travels. Laser light it is going to travel only in single direction. Okay. Directional and enti. Directional means where we have laser light traveling in single direction. Suppose if I take a room, okay, in that room, if I switch on tube light, that tube light it is going to illuminate entire room. But whereas in that room, if I keep laser source and if I try to illuminate entire room, it is not possible because that laser light it will go in single direction, it won't spread in entire room. That's why we cannot illuminate room using laser light. So that property is nothing but directional. Directional means where all beams of laser light they are going to travel in single direction. And what is the second point? So this is our first point, and second point is it can travel long distances without divergence. Without divergence means without spreading. So divergence is nothing but without spreading. So it will travel in single direction without spreading. And third point is its angular spreading is less and it occupies less area where it is incident. So you must be knowing about laser pointers. So if you take those pointers and if you make it fall on the wall, you'll be able to see single spot. It means that all the beams of light, they are going and occupying small area. So this is the third property of being directional. And fourth one is directionality can be expressed in terms of divergence. So what is the formula for divergence? Just note down this formula for divergence. So divergence delta theta, it is given as R1 minus R2 by D2 minus D1. What is R1 and R2? R1 and R2 are radii of laser beam. So here what I'm going to do here is, see here, I'm going to take one screen. Suppose this is my screen.
Ma'am,
Ma,
slide change
Slide
అవ్వలేదు
change
ma'am.
కాలే మ్యామ్.
అవ్వలేదా? మరి ఇప్పుడు చెప్తారేంట్రా మొత్తం స్టోరీ అయిపోయినాక? Now?
ఇప్పుడు అయింది
Yes
మ్యామ్.
ma'am, ఇప్పుడైంది ma'am.
Okay, so note down this. So just note down these points. So what do you mean by being directional? Where laser light travels in single direction. And second one is this divergence is negligible. What do you mean by divergence negligible? Its angular spreading will be less. And then fourth one is directionality. It can be expressed in terms of divergence, and this is the formula for divergence. So what is this formula? What we'll do, I think some of you have done laser experiment in the lab, right? I'll take laser source. Suppose this is our laser source. Now light from this laser source, I will make it fall on the screen. This is my screen. So this is our screen. Okay. First, what I'll do, I'll maintain this laser source and screen at one particular distance. Let that distance be d1. And if I make light from laser fall onto the screen, here I'm able to see one spot. Okay, you'll get one spot because of this laser light. Now what I'll do, this spot diameter I'm going to find. And the diameter, after finding diameter, I'll find radius. So let us suppose that radius of the spot is R1. Then after that, what I'll do, I'll move this screen little bit towards the laser source. It means that I'm maintaining distance between laser source and screen D2. Then what you will observe here is the spot which is recorded on the screen, its radius, it will get changed, and let that radius be R2. And then once I know the radius of the spot at two different distances, then how can I find divergence? Divergence is simply R1 minus R2 by D2 minus D1. And it has been observed that divergence for laser beam is some 0.01 milliradian. Whereas if you take normal light, it is 0.5 radian. It means that spreading of light is very, very less in case of laser light. And if spreading is less, that property is nothing but being directional. I hope you are clear about directionality property, students. So shall we go for second property? I think it's 11 times, students. So rest of the properties we are going to discuss in the next class. So we have started with third module. We said that there we have lasers. So what is the full form of laser? Light amplification by stimulated emission of radiation. And we are saying that when we compare laser light with normal light, it has got four characteristics. What are those four characteristics? Directionality, monochromicity, highly intense, and coherence. So in that we have discussed first characteristics. So remaining three characteristics we are going to discuss in the next class. Okay, students. Is it clear? Any doubts? Okay, so shall we end our session? So I'm ending my session here, students. You can join for next class. Okay.